And 6.4 graphs of sine and cosine functions. So after we're done with these sections, we will quiz, basically. So either Monday or Tuesday next week. All right, so the parent functions for sine, that's what I'm going to do first. So sine is going to go out to 2 pi and negative 2 pi because we're just going to do the full thing. It won't always be this, but for the parent function it is.
Is this stuff easy?
The parent functions are. I mean, the setup of the other ones is not hard. The actual graphing tends to be where people get a little confused. So. Are any of y'all planning on taking pre-cal next year?
I don't know what any of that means. What is pre-cal?
What is next?
I don't know what math is.
What is next?
Pre-cal.
What is pre-cal?
Or
Is it
stats. Those
like
are your two
algebra
options
or
pretty
like
much.
geometry stuff?
Pre-cal is this, but a little more advanced.
Pre-cal is? And then what's...
Stats as your other option, where I cover 27 chapters in like 32 weeks.
What do you think the smartest one for us is?
If you don't need stats in the future, I would not take stats.
Boost stats.
How do
Cause
we
stats.
know if we need stats in the future?
Based on what you're going to major in college.
I'm going to major in my parents' basement.
I'm sure they love that.
They don't have a basement, so... Chilling.
Because your answer to this question is going to depend on how much we do with this section.
I'm not taking it next year.
You'll be at a disadvantage if you tell me you're not and you are.
Wait, I think I'm going to take pre-cal, right?
Yeah.
Okay. I'm taking the one that I like is easier
The
because
better
I'm not trying to kill my brain.
Yeah. Okay. Then we're going to do graphing.
I like the algebra stuff.
Stats is fine. It's just a lot of thinking. There's not a lot of math, and it's a lot of writing. Like, I mean, it is math, but like,
Does Nathan
it's a
take
lot
that
of
class?
writing. Yeah.
Yeah, I cannot compete with Nathan. I bet-
Josh Krebs is in there right now.
Okay, yeah.
So
Those guys are on a different level of brain functions.
college stats isn't bad. AP stats is awful.
So high school's harder?
I think it is. I mean, I didn't take that one. I just took college stats, but teaching it, I think it's harder. Okay, so with sine, okay, if I were to ask you what the sine of 0 is, okay, so on the unit circle, okay, if you have your circle over here, what is the sine of 0? What's the y value there?
Undefined. No.
Y value. On the right axis.
0.
0. So when we start our sine graph, it starts at 0.
Okay.
What is the sine of pi over 2? So what's the sine on the axis going up?
1.
So the next point is at 1.
Okay.
What's the sine of pi?
Sine of pi?
So on the left.
0. And negative 1, I mean.
0.
Wait.
Sine is y.
Oh, yeah.
All right, how about 3 pi over 2? So going straight down.
2. Negative 1. No, I mean 0.
0. No.
Wait, undefined.
Y value.
Wait, negative 1.
Negative 1.
I wrote it wrong. This is my quiz, and then you corrected it, so I'm confused.
All right, sine of 2 pi. So all the way around to the right again.
0.
0. All right, so notice. Whoa, come back.
Oh, this is cool. I saw this on someone's paper the other day.
Hmm?
I saw it on like someone who's taking this right now.
You are?
I saw it up on the board or something. It's like a squiggle line.
Oh. I thought you meant what just popped up on my screen. I was like,
Oh.
what? 2 classes have done this recently. All right, so look, it goes up, down, down, back up, and the pattern would keep going, okay? So over here, if I want to work backwards, okay, this was going down, so over here it's going to be down, back up at 0, up at 1, and back at 0. So when I connect it, it's not like this. Nope, it's not like this, like a V, okay? It's nice and curved.
How come it's curved?
Because it's a sine function. It just deleted it. Okay, let's try this again. Okay, close enough. So that's the parent function for sine. So if I tell you to graph the parent function for sine, this is what I need. You look like you have a question.
Yeah, so it's just like these ones. So you start here and you go. Wait,
Yeah. I mean, I would just memorize that sine always starts at 0 and goes up.
0 and you go here and you go here and you end it back here. Okay, that makes sense.
But I mean, like, it's easier just to memorize it, but I'm trying to show you where it comes from since y'all have never seen these before. All right, so that was sine. So now we're going to look at cosine. So the parent function for cosine. So the setup is going to look exactly the same, just the points on the graph are going to be different. All right, so cosine, we're going to look, same thing. So the cosine of 0 is what?
1.
1. How about the cosine of pi over 2?
0.
0. Cosine of pi?
-1.
-1. Cosine of 3 pi over 2?
0.
And cosine of 2 pi?
1.
So with this one, okay, if you notice, it starts at 1, goes down, and comes back up. So it kind of looks like a V. Okay, so the other direction, or when we go backwards, it's going to go down, down, back up, and up. So again, still rounded.
It's a W.
So this one is kind of like 2 V's or W attached together. So if I tell you to graph me the parent function for cosine, this is what you need to give me. Okay? Eventually we will graph all 6 trig functions. But right now we're just doing these 2.
Are they always gonna look like that?
No, these are the only two that look like this.
Oh, I'm saying like if you said, graph the sine, you would just.
Oh, yeah. Now, that's true for the parent function. When I add more stuff to it, it'll look the same, but it won't be in the same spot. It's going to be shifted around. All right, I'm going to give you the rest of the notes that go with this stuff, and then we'll look at some examples of these. So, our functions that we're dealing with are either y equals a sine of bx or y is equal to a cosine of bx. So what this stuff tells us, what is happening? The amplitude is equal to the absolute value of a. Okay, so whatever number is in front of the trig function is your amplitude. I swear my iPad is possessed. Okay. So in the parent function, okay, there is nothing in front of the cosine of x. It's just cosine of x. So our amplitude was 1. Okay, because there's an understood 1 there. So that's why it goes up to 1 and down to -1. So the amplitude is each direction from 0. And it's the absolute value of it because it could hypothetically have a negative out front, which doesn't change what the number is for the amplitude. That'll just tell you something else in a little bit. The next thing is the period of the function, which is 2 pi over the absolute value of b. So typically our problems, b does not end up being negative, but it could be. So that's why we put absolute value bars there. But to find the period, we do 2 pi over b. Since we are going to eventually be graphing these as well, I used to just have people graph the parent functions, but in pre-cal and so on and so forth, you have to actually be able to graph them. So we'll be actually physically graphing all of them. But to do the scaling for the trig functions, it's the period divided by 4. So for our cosine parent function up here, the period is, we had cosine of x, so there's no b value, so it's just 1. So the period would have been 2 pi over 1. So 2 pi is 1 full cycle. So that right there is 1 full cycle on this side. Okay? So to scale it, we took the period, 2 pi, and divided it by 4. And when we did that, it gave us increments of pi over 2, and that's how we counted out what each thing would have been. Let's see, what else? If a is negative, then the function is reflected. So it just means it would be flipped upside down. If we had the functions, instead of just being a sine of bx or a cosine of bx, if I had y equals a sine of bx minus c plus d like this, or y equals a cosine of bx minus c plus d. then these are translations that are happening. Which this stuff is the 6.4 part here. So that'll be not today, but just so that you have the intro to it. So this is the translations. So C tells us if the function moves right or left. And it goes opposite the direction of the sine. So if I have negative C, this is moving to the left, or no, sorry, right. C units. Okay, because negative would imply that it's going left, but it's opposite, and so it goes right. If it's a positive C, this moves left C units. D tells us if the function moves up or down, and it goes the same direction as the sine. So if I have negative D, then that moves down D units. If I have positive D, then that moves up D units. So when you're solving these problems, this is what I want you to do, or when you're like working on these problems. I want you to first state the amplitude. Two, find the period. Three, find the scaling of the x-axis. 4, state any shifts up or down, or left or right. Now, a function can have both, but they don't have to. It doesn't have to have any of them, but it can. And then lastly, state if it's reflected. Now, steps 4 and 5 won't always have to be like you won't always have to have something written down for them, because sometimes the functions don't have those things happening. Okay, some functions don't shift at all, and some of them aren't reflected. So if that's the case, you can just disregard that. But steps 1 through 3 should always be there. And steps 4 and 5, well, 5 might kind of come in with this with 6.3 questions, but 6.4, you won't have anything from step 4 till we do those problems out of that section.